Aloha Algebra 1 students, this is solving a system of equations by substitution 2. So this is a continuation of yesterday's video. So if you flip open your graphic organizer, your foldable, it'll be on the inside. And again, we're going to start off with that same rule that we talked about in substitution 1. In order to substitute, you must have an equation that has a variable that is by itself. So again, let's go ahead and highlight that. The variable that is by itself. And as you can see, our variable that's by itself in our example here is our y. This y is by itself. If I was to look at this 4x, the negative 4 is with the x, and so this is not by itself. If I was to look at the 5x and the 5y, again, they're on the same side of the equation with coefficients, so these are not by itself. Again, but our y is by itself. So just a review from yesterday, when we have a variable that is by itself, we can now substitute. Go ahead and write this equation next to step 1, and we're going to go through the same steps that you did yesterday. The equations are just going to get a little bit more complicated or extensive. So we have y equals negative 4x plus 15. And because we can substitute, we're going to take what the y is equal to, and we're going to plug it in the variable in the other equation. And since this is y, we have to plug it into that y. Again, we're going to plug it into the other equation. We're going to take one equation, substitute it into the other equation, and we're going to take what the y is equal to, the one with the variable by itself, and plug it into the other variable. Okay, now this is what it's going to look like. We're going to drop down our 5x plus 5. And instead of y here, we're going to take this piece and we're going to plug it into the y. So negative 4x plus 15. We got that right from here. Negative 4x plus 15. And we took that, plugged it in the y. And we're going to drop down our equals and our 15. So this is our multi-step equation. And we've seen these types of equations before. Again, with parentheses, we have to distribute, and then we have to combine like terms, and then solve as a two-step equation. So let's get rid of these parentheses first. We're going to distribute our 5 out evenly to the other parts of the equation. 5 times negative 4x, and 5 times positive 15. And this is what we end up with. We drop our 5x here. 5 times negative 4x is negative 20x. 5 times 15 is plus 75, because positive is 75. And then we're going to drop the rest of the equation. Let's simplify. 5x minus 20x, we can combine those two because they're like terms. We're going to get negative 15x plus 75 equals 15. Now, at this point, it's a two-step equation. We have our coefficient, we have our constant, and we have our number that it's equal to. And so we want to get rid of the constant first. So minus 75 minus 75. We have negative 15x equals negative 60. You're going to solve for the x by dividing it by negative 15. Divide by negative 15. And x equals 4. Okay, so just like yesterday, we have only solved for one equation. We're going to take our x equals 4 and we're going to plug it back into either equation, the top or the bottom. But I want you to take a look at the equation and just see that because this is already a y equals, this will be the easier of the two equations to plug it back into. So I'm going to drop this equation here, y equals negative 4x plus 15 down here. And I'm going to take my 4 and plug it into that x. Right there. And so I'm going to end up with y equals negative 4 times 4 plus 15. Simplify it to y equals negative 16 plus 15. Negative 16 plus 15 is negative 1. And now I have my answers of x equals 4, y equals negative 1. Okay. Let's take a look at our second equation. And as you can see, let's go back to our rule. In order to substitute, you must have an equation that has a variable that is by itself. Now, as you can see, we do not have a variable that's by itself. The closest thing that we have is this x that has a coefficient of 1, but it's still on the same side as this 7y. And so when we are in the situation where we do not have an equation that has a variable by itself, we're going to solve for y. We're going to, or x. Whatever is the easier variable to solve for, that is what we're going to do. And because I know that I can easily get x by itself by just taking the 7y and pushing it to the other side of the equation, I'm going to solve for x here. So let's take this equation, x plus 7y equals 20, and let's minus the 7y to both sides. I'm going to minus 7y, and what's left? I'm going to drop my x, and on this side I have 20 minus 7y. Okay, so I have my x by itself. So now we're back to this situation. We have a variable that's by itself, and we have an equation that does not. So we're going to take our 20 minus 7y, and we're going to plug it into the other equation right there. This is x, and so we're going to plug it into the other x. Again, step 1. Substitute one equation to the other. So we're going to take this equation, plug it into the other x. And again, we chose this x because this is already equal to x. It's the variable that is by itself. Okay, let's rewrite it. We have negative 2, but instead of x, we're going to put 20 minus 7y. Continue it. Minus 5y equals 14. So we're just simplifying this equation after we substitute it. We have a parenthesis, so we know we're going to have to distribute the negative 2 to the 20 and the negative 2 to the negative 7y, and we're going to get negative 2 times 20 is negative 40. Negative 2 times 7y is positive 14y. We're going to drop the rest of the equation, negative 5y equals sign 14. And now we're going to combine like terms. 14y minus 5y is going to be equal to 9y. I want y by itself, so I'm going to get rid of my constant. My constant here is negative 40. I'm going to add the 40 to the other side. Because it's negative, we have to use the opposite operation, which is positive 40. Whatever I do to one side, I have to do to the other. And this cancels out to 0, like we like. And we're going to drop our 9y. 14 plus 40 becomes 54. We have 9y. We want y by itself. We need to divide to isolate the y. Okay, and we're going to come up with y equals 6. But are we done yet? Your brain should be saying, no, we're not done because we do not have x's solved for. Remember this equation in the very beginning that we isolated the x? Whenever we have this type of equation, these are the best equations to substitute back into for step 3. When we have a variable that is by itself. So this is the equation I'm going to use. X equals 20 minus 7y. We know that y is equal to 6, so I'm going to plug 6 right into the y. And I'm going to get x equals 20 minus 42. 20 minus 42 is x equals 22. And these are my final answers. X equals negative 22. Y equals 6. Okay, let's flip over to the other side of your graphic organizer. And we are going to look at another example. So here we see 6x minus 4y equals 22, x minus 5y equals 8. And your brain should be saying, or be telling you the rule. In order to substitute, you have to have an equation with a variable that is by itself. And we don't see any of that here. So we're going to make an equation with a variable by itself, which is, well, you can actually use any equation, but because we see that there's an x by itself, let's keep it simple and let's use the bottom equation. So we're going to use the bottom equation and say x minus 5y equals 8. Let's get x by itself by adding 5y to both sides. And we're going to end up with x equals 8 plus 5y. Again, I took that 5y and I added it over to the other side. Okay, so now we have a equation with a variable that is by itself. So we're going to substitute step one. Substitute one equation into the other. So we're going to take this whole piece here, and we're going to plug it into that x in the top there. Let's rewrite it. 6 times, instead of the x, we're going to say 6 times 8 plus 5y. Take this whole thing, plug it in there. And we're going to continue this equation. Minus 4y equals 22. Now we're going to distribute 6 times 8 and 6 times 5y. So 6 times 8 is 48. 6 times 5y is 30y. Let's drop the rest of the equation down. Next, we're going to combine like terms. Because we have 2 different sets of variables, we can only have one. So 30 minus 4 is 27. Sorry, I'm wrong. It's 26. We're going to push our 48 to the other side. So minus 48. Whatever you do to one side, you have to do to the other. Minus 48. And we're going to get negative 26. And again, we want y by itself. So we're just going to divide it by 26 on both sides. We're going to get y equals negative 1 because negative 26 divided by positive 26, negative 1. And in your mind, you should be saying, we are not done yet because we still don't know what our x is. But because we already manipulated this or changed this around so that we have it equal to x, it's going to be easier. We're going to take our negative 1 and we're going to plug it back into that y. We're going to get 8 plus 5 times negative 1. So this is 8 plus negative 5, which is positive 3. So now we have our x equals 3 and our y equals negative 1. Let's go ahead and box our answer. And let's move on to the next example. Okay, here's our next example. We have 6x plus y equals 7 and negative 6x minus y equals 6. And again, our brain should be going back to the rule of substitution, that in order to substitute, we have to have a variable that's by itself. And your brain should also be saying, but Miss Ledger, there is no variable that's by itself. You are right. And we need to create an equation or manipulate one of the equations so that we do have y by itself. Now, as you can see, we have positive y and negative y. And both of these have good things about it. If I was to use the bottom one, I would have a positive 6x because I'm going to move it over, right? But then I'd end up with a negative y. As opposed to if I use this y, I could move the 6x over and I would have a negative 6x, which is again not bad, but at least I'd have a positive y and I wouldn't have to do an extra step. So I'm going to choose to use this equation, 6x plus y equals 7, and I'm going to manipulate this equation to get y by itself. And I'm going to push it down below that equation, 6x plus y equals 7. And I'm going to get y by itself by moving the 6x over to the other side. So minus 6x minus 6x. I'll have y left over on the left side and 7 minus 6x on the right side. Now I have a variable that is by itself, and I can substitute this equation back into this other equation right here. Okay, so let's try it. 7x is going to go right there. So I'm going to write out this equation, but instead of writing the y, I'm going to take this 7 minus 6x and plug it right there. Now, you may look at this and say, oh, there's nothing to distribute. But remember, there's an imaginary negative 1 here. So I'm going to take the negative, and I'm going to distribute this negative to the 7 to make it negative 7. And just take this negative and distribute it to negative 6x to make it positive 6x. I'm going to drop everything else down. I'm dropping down negative 6x and equals 6. Okay. From this point, we're going to move our numbers to the right side because we like numbers on the right side and variables on the left. So I'm going to add 7 to both sides. And I'm going to combine 6x and negative 6x, and we're going to get 0x. 0x equals 6 plus 7, we get 13. Now, we want x by itself, so we have to divide by 0. And in your mind, you should be saying, but Ms. Ledger, we're not allowed to divide by 0. You're right. We can't divide by 0 because that is our unspoken rule. So we're going to look at our x and understand that 0x's is not equal to 13. And because we have a 0x that says it's equal to 13 and we know it is not true, we're going to say this is a no solution. No solution. So one way that we can see that is back here. If I was to change the signs, we would have seen that we had the same slope, right? And same slope means that it is parallel, also no solution. So when we have a 0x equal to some number, we know that it is not true, and we're going to have no solution. Now, there is one other solution that we haven't seen yet in substitution, and that's infinite solutions. And we're going to get infinite solutions when we have 0x is equal to 0. If we ever have 0x is equal to 0, we know that's true, and we would have infinite solutions or infinity sign solutions. Infinite or many, many solutions. Okay, so that's the lesson for today. If you have any questions or concerns, make sure that you're emailing me or coming in to get clarification. Thanks. Have an awesome day.